Hey folks, how's it going? It's Mr. Murray coming to you with a do now for Course 1 Honors for Wednesday, May 27th, 2020. And wow, can you believe we are already into the middle of the week already? Wow. All right, so today we are going to be going back in and talking more about some exponential equations. So here's what we've got. We've got two equations here. These are exponential equations. And so the goal here is going to be to find the value of x that makes both sides of the equation equal. If you haven't seen the materials about solving exponential equations, including the video that I put together, I recommend you watch that video before attempting these, as well as if these seem too difficult. It's better to kind of take a step back and make sure you're in a good place so that you can try to tackle these problems rather than kind of just watching what I do. So the more of the problems you can do, the better. All right, so please take a moment, pause the video, try to solve these two equations, and then when you're ready, unpause, and you can see what I got. All right, so the key to solving these is going to be using what we call the one-to-one property. And the one-to-one property says that if you have two exponential expressions that are equal in value and whose bases are the same, then that means that the exponents must also be the same. So remember, the strategy is bases alone, so to speak. Rewrite the right-hand side as a power of the base that's remaining. Take the exponents and bring them down, and then solve. Okay, so if you look up here on the first one, my base is not alone. So what I'm going to do is I'm going to start by dividing both sides by 2. So I've got 3 to the power of 2x plus 1 is equal to 27. Now the base is alone, and my goal now is to write 27 as a power of 3. So 27 is equal to 3 to the power of 3. And now we have two expressions that are equal to each other and whose bases are equal. So what that means is the exponents must be equal. And again, this is because of the one-to-one rule. The rule that says every input has one output, but every output also has one input. So if I'm plugging in 2x plus 1 and I'm getting into this function 3 to the x, and I'm getting the same output as 3 to the 3, then there's only one way to get that. All right, there's only one possible way you could be getting that output of 27, and that is when the exponent is equal to 3. Okay, as opposed to, and I think I mentioned this in the video, quadratics, where if we got like 81, like x squared equals 81, well, x could have been 9 or negative 9, and that makes the problem, have a little bit of a different answer. Okay, so if 2x plus 1 is 3, then subtracting gives us 2x equals 2, so x is equal to 1. Checking our work, 2 times 1 is 2, plus 1 is 3, 3 cubed is 27, and 2 times 27 is 54. All right, so let's come on down to the next one. So I'm going to start by multiplying both sides by 2. The reason I'm doing that is because, see, now I have a half instead of 2. So when I've got a 2, I need to divide so they cancel. When I've got a 1/2, I need to multiply so they cancel. And then what you do on the left, you do on the right. Over here, I'm going to cancel this 2 rather, with the 64. So I've got 2/3 to the power of x equals 243 over 32. Now, if you know your powers of 2, what you know is that these are actually kind of crisscrossed. I'll show you what I mean. So my goal is to write the left-hand side, or the right-hand side rather, as a power of 2/3. Because if I can get these bases equal, I can just bring the exponents down, solve for x, and I'm good. Okay, so here's the issue. 243, all right, this is 3 to the 5th. And 32, that's 2 to the 5th. So basically, I've got these crisscrossed. So what I'm going to do, the first thing I'm going to do, because I've got them crisscrossed, is I'm going to make the exponent negative. Making the exponent negative will take the 2/3 and automatically flip it to 3/2 before we go about actually finding what the rest of it is. So for example, if this was to the -2, first we would flip before doing the -2, or rather the +2. So in any case, we know that 3 to the power of 5 is 243, and 2 to the power of 5 is 32. So if I make this a -5, that first will flip it up, so it will become 3/2, and then the exponent will become a +5, and then 3 to the 5th is 243, and 2 to the 5th is 32. Remember, in this case, you kind of quote-unquote distribute that power like this. Okay, so 2 to the x is equal to, or rather 2/3 to the x is equal to 2/3 to the -5, and because of the one-to-one property, x is equal to -5. Checking our work, 2/3 to the -5 is 243 over 32. Multiplied by a half means you just take the denominator and multiply it by 2, and 32 times 2 is 64. So that brings us to the end of these two. Hopefully you're able to get these right. Just to recap, our answers are x is equal to 1 and x equal to -5. You can have positive and negative answers for these. Just keep that in mind. All right, folks, so please take a moment to ensure that you're finishing up all of your work with exponential equations, including watching the video and doing those problems, doing the do now problem that was assigned for yesterday as well as today, and completing 80% of the My HRW assignment. I've been, taken the effort to kind of split it up over 2 days in order to give everyone more time. So please, I'm hoping that you'll meet me halfway by then making sure the work gets done. All right, so keep it up. Keep that good work coming. Let's close the year on a good note. Don't forget to love math. And remember, you can do it.